notice that it has perfectly marked each persons with their object IDs, and it has also detected buses, persons, everything. And then here as well, you can see it has detected persons and it has also detected the tie as well, which means our engine file is working perfectly. Hello and welcome to Rocket Systems YouTube channel. In today's video, we are going to run a YoloV5 model by converting it into a TensorRT engine and then finally running it on Jetson Nano. So in some of our previous videos, we have been doing inferencing and object detection using SSD mobility models. Now SSD mobility models work perfectly fine on these embedded devices like Jetson Nano or Jetson Xavier, but because SSD mobility models are very lightweight models, so they are not very good in accuracies. But YoloV5 models, they are a bit heavy models, but they are very accurate in object detections. Now, if you normally run YoloV5 models on Jetson Nano without conversion or without optimization, you will have a very low frame rate. And this is why it's always a good idea to convert or build your YoloV5 model with help from TensorRT. Because once you have the TensorRT engine from the YoloV5 model, then you will have a better performance on Jetson Nano. So in this video, we are going to take a pre-trained YOLO V5 model. We will convert that into an engine and then we will do inferencing on Jetson Nano. So let's get started. Now I'm connected to my Jetson Nano using this No Machine software. So if you want, you can install No Machine on your Jetson Nano, or if you're comfortable with VNC, you can even install VNC on it. If you don't know how to install No Machine, you can watch some of my previous videos where I've explained how you can set up No Machine on your Jetson Nano, and then you can install No Machine on your Windows or Ubuntu laptop to remotely connect to your Jetson device. Now another thing I'm going to do is that I actually don't like this default desktop environment which comes with the Ubuntu installation. So I'm going to install XFCE, and I would highly recommend you also install the XFCE on your Jetson Nano, because XFCE is a very lightweight and it feels very fast when you are connected to your Jetson Nano using remote softwares. Because if you are connecting remotely, then and if you're using this default desktop environment, it becomes very laggy and it feels like very delayed. So I would install XFCE. If you don't know how to install XFCE, you can watch my previous videos. I'll put the link in the description and you can follow the videos from there. So now I'm going to open the terminal and I'll first update. Done. Now I'm going to install XFCE, and then once it is installed, then we'll resume the video. Okay, so I have installed XFCE, and it's up to your choice whether you want to go with the XFCE or the default desktop environment. But I would definitely recommend you install XFCE instead of the default desktop environment. Okay, so when I was doing my study on how we can convert the YOLO V5 model into a TensorRT engine, so this is the repository which actually helped me a lot, because this repository has the files through which I converted my YOLO model into a TensorRT engine. And obviously this is the repository which is the official repository of the YOLO V5 model. So what I've done is that I have combined these two repositories into one repository, and inside this repository you will find all the files you need in order to convert your YOLO V5 model into a TensorRT engine. And this repository also contains the scripts, Python scripts, through which you can do inferencing and object detections on maybe RTSP cameras or the USB cameras or the video file or the image files. So what I'm going to do is that I'm going to first clone this repository in the Jetson Nano, and then I will explain you how you can set up and install all the libraries which we need in order to convert YOLO models into TensorRT engine. Okay, so let's go inside our documents directory. I will open a terminal here and let's type git clone. Okay, so this is done. Now let's move inside this repository. Now, before we can start the conversion process from YOLO V5 to TensorRT engine, we have to install a lot of libraries. So I have created a file which is this setup.txt file. Let's open this file. Perfect. So there are few libraries which we need to install. So these are some of the normal APT libraries which we can install. After that, we need to install some of the Python libraries, and then we obviously have to install PyCuda, which is very, very important. And then after that, we have to install Torch and Torchvision. So let's start by installing all these libraries one by one. So I'll open up a terminal, and then here first let's update our system. Okay, now we have to install all these packages. So let me just quickly copy all these packages, and then let's paste this and hit enter. So this is done. Now we need to install the Python 3 pip, which is the package manager for Python, because we will be installing Python packages. So this is done. Now let's first update our Python package manager. Okay, this is also done. Now basic installation is done. Now we need to install the Python packages, and here you need to make sure that you exactly install these versions, because previously I've done it many times, and sometimes I installed some other version and some packages were not compatible with some other packages, so I had a lot of issues, and then finally I came up with this versions of these packages. So please make sure that you install these versions. Now, one of the issues is that NumPy already comes pre-installed when you install the Jetpack OS. So, but the version is different. So let's first quickly check which version of NumPy is installed. So the NumPy version is 1.13.3 and we need 1.19. So make sure you uninstall this version first, and then only install the version which we need. Because if you install this version, if you don't uninstall this version and you install the newer other version as well, then you might have few issues. So I think it is permission denied. Let's try this with sudo. I'm not sure why it's showing permission denied. Okay, I think it has now successfully uninstalled NumPy version, but we need to first make sure that it's properly uninstalled or not. So I'll import it again. And okay, now because it says no module found, that means it's now uninstalled. So now we can install Python 3-m pip install numpy version is 1.19.0. Yeah, 1.19.0. So 1.19.0. So it's downloading the 1.19.0 version, and it has installed. So let's open up the Python terminal and let's check the version. Now it's correct. Now let's install some other versions, other packages as well. So we'll install pandas. Okay, so I think this is already installed. Now let's see what we have to install. So next we'll install pillow. Okay, so pillow is also installed. Next we will install PyYML. Okay, so this is also installed. Next we'll install SciPy. Okay, SciPy is also installed. Next we have to install PSUtils, and we can install the latest version so we don't have to worry about the version for this particular package. Okay, so PSUtil is also installed. Next let's install TQDM and then IMUtils. Okay, so it's also installed. Now last package we need to install is IMUtils. Okay, so IMUtils is also installed. Now most of the packages which we need for Python is installed. Now next we need to install is PyCuda, which is also very important for our scenario. So let's install PyCuda now. Okay, so in order to install PyCuda, we need to export few paths first. So let me just quickly copy this and I'll clear this and let's paste this here. And then let's also copy this. Now we can simply install PyCuda by using this command. Now this can take some time to install, and during the installation you might see some warning or some error messages, but just ignore those messages and at the end it will show you that PyCuda is installed. Now make sure to copy and paste this whole export path. If you try to type it down by yourself, then you might do some mistake and then it will not be properly exported and then PyCuda installation will probably fail. So make sure to copy and paste this whole export path and then only install the PyCuda. And anyways, and you can anyways download this whole repository, and then from there you can copy all the commands which is inside the setup file. So let's wait for this to install. It can take up to I don't know, maybe 10 to 15 minutes, and then we'll resume this video. Okay, so PyCuda is now installed, and you will see that there are few warnings and the error messages appear, but we can safely ignore them because at the end the PyCuda is finally successfully installed. So this step is also done. So next we need to install Seaborn. Now you can install Seaborn using pip package manager, but using the pip package manager it takes a lot of time. So the easy way to install Seaborn is using apt package manager. So let's copy this command. Okay, so Seaborn is also now installed, and the last installation which we have to do is Torch and Torchvision. Now you can, I mean, if you are, let's say in Ubuntu or any other system, you can easily install Torch using the pip package manager. But in case of Jetson, you cannot do that because Jetson it has a different architecture. So NVIDIA has released its own page where they have explained how you can install Torch and the Torch Vision. So I have included all those steps here in this file as well. But if you want to follow their guide, I'll put the link into the description. But anyways, both of the steps are same. So I'm first going to install Torch, and the version which we are going to install is 1.10, and the Torch Vision we are going to install is 0.11. I have tested these versions, they work perfectly fine on Jetson devices, but if you want, you can install any other version as well. So let's first go and download the Torch wheel file. Now for this, I'll move inside the downloads directory because I like to keep all the downloads in the downloads directory. Okay, now we can easily install this Torch by using the Python command pip3 install. So let's copy this and paste it here. Okay, so the Torch is now installed. Now let's install Torch Vision. So first let's clone its branch. Okay, so this is cloned. Now let's move inside the directory, and then we can simply run this command to install Torchvision as well. So let's copy this and let's paste this here. Okay, so Torch and Torchvision both are now installed, and this also completes all of our requirement, all the libraries and the Python packages which we need in order to build the YoloV5 into the TensorRT model. If you want, you can also install Jetson Stats. It's a very good library in order to monitor your Jetson hardware performance. So I'll just quickly install this as well. Perfect. So I'll install this library and then we'll reboot the system and then we will start our process of converting the YOLO V5 into the Jetson. So it looks like it needs the sudo command. Okay, so once this is installed, I'll reboot this system and then we will begin our main actual process. Okay, so our requirements are all complete. So I'll close this file now. And then inside our clone repository, you will find another file, which is this buildsteps.txt file. Now this file contains the list of commands which we need to run in order to convert our YOLO V5 model into the engine file. So for this video purpose, I'm just going to use the YOLO V5S, which is the small version of the YOLO V5 model. But if you want, you can also go with the large version or the extra large version. But ideally, I would recommend on the Jetson Nano you go with the small or the nano version, because these are the lightweight versions of the YOLO model. Otherwise, the large and the extra large models are very heavy and they will perform very slow even after converting into the TensorRT engine. So we will proceed with the YOLO V5 small version, and I've also provided both YOLO V5 nano version and YOLO V5 small version, so you don't need to download the model separately. So I think let's start by converting these YOLO models into engine file. So the basic step is that we will first convert this PT file into a WTS file, and then by using this WTS file we will build the engine file, and then obviously based on the engine file we can do inferencing over the images and so on. So let's first open up the terminal here, and then I will copy this first command which will convert my PT file, which is the YOLO V5S PT file, into the WTS file. So I think I've also provided this WTS file, but for now I'll delete this file and paste it again. So this conversion can take up to probably like 4-5 minutes, so let's wait for it to convert. Okay, so this is done. Now next thing which we need to do is we need to move inside the YOLO v5 directory, which is this directory, and then inside this directory we need to create a build directory, and then we need to copy the generated WTS file inside the build directory. So from the terminal, let's move inside the YOLO v5 directory. Let's make another directory here, and let's move inside the build directory, and then let's copy the WTS file inside this build directory. Now another thing which we need to make sure is that obviously we are using this pre-trained model which is trained over 80 classes, but if you are using your own custom model, then you need to update the number of classes which you have inside your custom model. So for that, if you go inside this src, you will find this config.file, and then inside this config.file you will find this variable here, knum classes. So whatever number of classes you have trained your model for, maybe 1 2 3, you need to update this variable. But in our case, because we are using the pre-trained model, so we don't need to do any change here. So I will close this, and and inside our terminal we will we will run Cmake, and then we will run the make command. So this is done. Now we will run the make command. Okay, so this is also done. Now we can, let's go back to our file. So we can simply build the engine. So I will use this command, and then let's build the engine file. Now this engine file can take up to 10 to 15 minutes. So we'll resume once that is done. Okay, so the engine file now has been successfully built. We can go inside our build folder, and here is the engine file. So this is now the TensorRT built engine file. So this will perform better than running directly YoloV5 on your Jetson device. Now, in order to test whether this engine file is working perfectly fine or not, let's run this command. And probably with this command, it will inference over the image files, and then we will see if it's doing the detection or not. So let me just quickly clear everything, and then let's run this. Perfect. So basically what it has done is that we have some of the images stored inside this particular directory, and this image directory has, some persons, some buses and everything, and then these also have some persons. So we have done inferencing over these two images, and the output is saved inside this build directory. So if I open this bus.jpg, you will notice that it has perfectly marked each persons with their object IDs, and it has also detected buses, persons, everything. And then here as well, you can see it has detected persons, and it has also detected the tie as well, which means our engine file is working perfectly fine. And this is how you can convert your YoloV5 model in into the TensorRT engine, and then you can probably run it on your Jetson Nano device. So that's all for this video. In the next video, we will write a Python script through which we will do inferencing over a video file, or maybe a USB camera or an RTSP camera. So that's all for this video. Thank you for watching this video. Please like, share, and subscribe to the channel.